A normal curve is a type of density curve. Density curves always have an area of exactly 1 underneath it and are always on or above the horizontal axis. Any density curve can be described by the acronym SOCS, but more specifically, normal curves are unimodal, symmetric, single-peaked, and bell-shaped, have no outliers, are centered at their mean and median, and have a spread that follows the 68, 95, 99.7 rule. Starting off with the 68, 95, 99.7 rule, the standard deviation is the distance from the center to the change of curvature inflection points on either side. The 68, 95, 99.7 rule states that for normal distributions only, about 68% of the observations are one standard deviation above and below the mean, about 95% are within two standard deviations above and below the mean, and about 99.7% are within three standard deviations above and below the mean. To standardize your data, we will be using z-scores of your observations, and z-scores are found with the formula z equals x minus the mean divided by the standard deviation of the data. In order to get all of the points on the AP tests, you should always show your work, show the original formula of how to find the z-score, so x minus mean divided by standard deviation, draw the normal curve and shade in which interval you're finding the probability of, and also state the mean and standard deviation. When you are given a set of data and you don't know the mean or the standard deviation and you have to find your z-scores, you can simply go to Stat, Edit, and input all of your values. Then you press Stat, go over to Calc, and do one variable stats, and you have your list as list 1 because that's where we put all of our data points in. We leave the frequency list blank and calculate, and that gives you the mean at the top, and standard deviation is 7.85. To find the z-scores, you would use x as whatever value is here, and then use the mean and the standard deviation that they give you. And in cases where you know the area under the curve or the probability of getting a certain value, you can use the inverse norm function, which can be found by pressing second vars, and it's number 3, which is the inverse norm function. So let's say that the area is 0.95. And I'm trying to find the corresponding z-score that gives me 0.95. So I would set the mean as 0 and the standard deviation as 1, and I would paste and press enter, and that gives you 1.64. Another thing to keep in mind is that the probabilities shown are the areas to the left of the z-score, or probability of getting the corresponding z-score or less. That being said, when you have to find a probability of getting a certain value or higher, you would first need to find the z-score of that value, and the probability would be found by subtracting the given probability from table A from 1. When is a distribution normal? You can see if a distribution is normal by using the large sample condition or large counts condition. The large sample condition is used for confidence intervals and tests about means. The central limit theorem says that when n is large, the distribution of sample mean x bar is approximately normal. So for the large sample condition, if n is greater than or equal to 30, we assume the distribution is normal. On the other hand, the large counts condition is used for intervals and tests about proportions, chi-square tests, and tests and intervals about slope. The large counts formulas are different for each type of test or interval, so make sure you're using the right ones. A normal probability plot measures expected z-score over x values. In order to see if your data is normally distributed, first put all of your data points into list 1, which can be found through Stat and Edit. So you put in all of your points, and then you press second y equals, and you're going to go to plot 1, and that has to be on. And the normal probability plot is found on the last icon of the type. So press that, and your data list was list 1, and your data axis is x, and you're going to press graph. If the data on the plot shows a linear positive pattern, the data is approximately normal. If the plot shows data points that are far away from the overall pattern, outliers, or if the data is not linear and shows a curve or a skew, then the data is not normal.